oranges, then you can conclude that you have apples and oranges. Okay? So that's this inference rule, which is known as conjunction. When you memorize this inference rule, the way that you should memorize it, again, like all other inference rules, is what that inference rule does for you in a proof. This inference rule allows you to create a conjunction, okay, with given premises, okay? So anytime when you're doing a proof, you need a conjunction, okay? You can use this inference rule to create that conjunction as long as you have the two parts that make up the conjunction, okay, as premises, okay? Here is simplification. Simplification is basically the opposite of conjunction, okay? So this tells you that when you have a conjunction, okay, when you have P and Q, you can conclude one of the conjuncts, okay? In this case, the first conjunct, okay? So if I have apples and oranges, okay, then from that I can conclude that I have apples, right? So if I have apples and oranges, then from this statement I can conclude I have apples, okay? So what simplification allows you to do is conclude the first conjunct from a conjunction, okay? So if you need to basically take apart, okay, a conjunction to get the first conjunct, then what you should use is simplification, okay? Finally, here we have addition, okay? Addition is probably the inference rule that confuses most people, okay? And it kind of seems to be the case because they think it's magic or something like that, but it really isn't, okay? The reason why addition is allowed is because of the truth function of the disjunction, okay? So, how does addition work? Well, addition says that if you have any statement P as a premise, okay? So if I have apples as a premise, okay? Then you can conclude the disjunction, okay, of the premise that you have, in this case I have apples, along with any other statement Q, okay? So if I have apples, then from that statement I could validly conclude the statement I have apples or pigs fly, okay? Or I can conclude I have apples or aliens exist. Or I can conclude I have apples or I'm a millionaire. Or I can conclude I have apples or the kitchen sink, okay? So basically from any statement P, you can validly conclude the disjunction of that statement P and any other statement, regardless of what that other statement is. Why? This is because of how disjunction works, okay? You can actually create a truth table for this argument where you have P as the premise and P wedge Q as the conclusion. You'll see that this is a valid form. It's not possible for you to actually have all true premises and a false conclusion with this form. And I'm not going to do it for you. I'm going to leave it up to you to do. And if you get something where your truth table actually says that it's invalid, post the discussion comment because you've done something wrong, okay? So the way that you should use addition is this. If it's the case that you need to introduce a certain statement, okay, either a compound or a simple statement, then you can use disjunction to do so, okay? But you should be really careful when you use disjunction to introduce a statement, okay? Because the only way that you can actually end up using that statement, okay, once you've introduced it, is if you already know that you have a not P, okay, the negation of the first disjunct in order for you to derive Q using DS, okay, using disjunctive syllogism, for you to be able to use that disjunct that you've introduced. So when you use addition to introduce a statement that you need, okay, you have to do it very carefully. You can't just like willy-nilly try to introduce statements all the time that you need, okay, because it doesn't matter if you can introduce it into a disjunction if you don't have a way of getting it as an independent conclusion, okay? Because once you've introduced it using addition, that statement, compound or simple, will always be attached to that P, okay, as a disjunction, unless you have some way of taking that disjunct out as its own separate conclusion, okay? So don't start going crazy with addition and just start adding a bunch of stuff because you might not be able to use it, okay? Okay, so let's look at these forms, these three, simplification, conjunction, and addition, a little bit more closely. We have already looked at constructive dilemma, so we're not going to talk about that. However, I will tell you this, okay? One thing that you should think about in terms of when you might need to use constructive dilemma in your proof is this. When you see that you need to derive a disjunction, okay? And not only that, but you see that the disjunction that you need to derive is constituted by parts of a conjunction that has conditional statements in it, okay? Then you should think to yourself, I'm probably going to need to use constructive dilemma, okay? So here you have one way of getting a disjunction, right? And this is another way here through addition that you're going to be able to use disjunction. So anytime when in your proof you need to get a disjunction, you should think to yourself, okay, here are my two possibilities. I can use constructive dilemma or I can use addition, okay? But in order to decide which of those two that you are going to use, you have to look at what you already have, okay? If you have conditional statements or a conjunction of conditional statements where those conditional statements have parts of the disjunction you'll need, then you should think, I'm going to need to use constructive dilemma, okay? But if in what you have, you don't have anything else except for one of the disjuncts that you'll need, okay? Then you should think, I'm going to have to use addition, okay? So those are the ways that you should think about how these inference rules will work for you in the natural deductive proof, okay? Okay, so let's look at simplification in a little bit more detail, okay? So simplification is any uniform substitution instance using simple or compound statements of the argument form, this. So this is the form of simplification, and here are two examples of simplification. Notice how here in this example you have as the premise the conjunction of two statements. So the premise is a conjunction. Here's the main operator, and it brings together the negation of B horseshoe D and Q. And then you have as the conclusion the first conjunct, okay, the negation of B horseshoe D, okay? And here you have as the premise, okay, the conjunction, which is the main operator, of M and S wedge G horseshoe C, okay? And as the conclusion, you have the first conjunct, okay? Now here's an example of an argument that is not a conjunction, which you might mistake as a conjunction. Notice that there are two reasons why this is not a conjunction. The first is that the premise here is not a conjunction, okay? The main operator is a wedge, which makes this premise a disjunction. So this disjunction brings together P dot Q and R horseshoe S, okay? So because the premise here is not a conjunction, this cannot be in the form of simplification. Now let's say that instead of the disjunction, this was actually a conjunction dot, okay? Which means that here you would have a conjunction of P dot Q and the conjunction of R horseshoe S. Even if this change was made, this would still not be an example of simplification because the conclusion is P, okay? It is not one of the conjuncts that makes up the conjunction. Notice that one of the conjuncts is P dot Q, not just P. So this would be P corresponding to the P over there, and this would be Q corresponding to the Q over there. So here, the conclusion is not P, because P is P dot Q, okay? So the conclusion is not P, which makes it the case that this is not a simplification. However, if we change P, the conclusion, to P dot Q, okay, then we would have this example being an example of simplification because we have, again, a conjunction, okay, as the premise and the conclusion as the first conjunct, which in this case would be P, just like the P over there, okay? However, this argument was not given in this form, okay? it was actually given in this form here, which makes this, okay, a completely different argument, okay? So this argument here as it is given is not a simplification, okay? Let's look at another one. Here is conjunction. So remember, conjunction is the opposite of simplification. So with conjunction, you have any uniform substitution instance using simple or compound statements of the argument form here, okay? So you have P as one premise, okay, a separate premise on its own, and then Q as another premise, separate premise on its own. Then you can conclude from P and Q the conjunction of P and Q, or P dot Q, okay? So here are two examples here of conjunction. Notice how here you have a statement, okay, and this we can say is statement P, and here you have another statement here which is a compound, and this is statement Q, and as the conclusion you have the conjunction, okay, as the main operator of P and Q, okay, so this is an example of conjunction. Here's another one. You have a statement, and this one here is B horseshoe J, which we can say is P here on the conjunction form. And then we have the other statement, L horseshoe not F, okay, which is another separate statement, okay, and this can be Q belonging to Q over here. And as the conclusion then, we have the conjunction again of P, okay, which is B horseshoe J, and Q, okay, which is L horseshoe not F, L horseshoe not F, okay? So here's another example of conjunction. Here's an argument that might seem to be a conjunction, but it is not a conjunction. So notice here, we have the statement S, okay, which we can say is P, okay, and then we have the statement P horseshoe R, okay, which we can say is the statement Q, okay. However, as the conclusion, we do not have a conjunction of P and Q. We actually have the conjunction of P, okay, which is S, and some other statement, okay, not the statement Q, because Q is P horseshoe R, and here we have just P. So here we have the conjunction of P dot some other statement R, okay? So notice how this does not take the form of conjunction. So this is not an example of conjunction. However, if we change the conclusion, okay, so that's the main operator. If we change the conclusion such that the P was actually the conditional P horseshoe R, then we would have an example of conjunction. Why? Because here we would have a conjunction of P, okay, which is the first statement, S, and the conjunction of Q, okay, which is the second statement, P horseshoe R. Okay? However, this was not given to us in the original statement. Okay? So the original statement was simply this. Okay? So because this was the original statement, this is not an example of conjunction. Okay? Let's move on. Addition. Okay. So addition is any uniform substitution instance using simple or compound statements of the argument form here. Okay? So addition, if you have any statement P, then you can conclude from any statement P, P, wedge, any other statement. Okay? That Q can be any other statement you want. It can be a compound statement, a simple statement, a very complex compound statement, whatever statement you want. Okay? So here are two examples of addition. Okay? So notice how here we have the statement S, okay, which corresponds to the P in the form over there. And as the conclusion, we have the statement S, okay, as part of a disjunction with the statement Q dot R, which in this case corresponds with the Q in the form of the addition. Okay, so we have from statement P, which in this case is S, we can conclude S wedge Q dot R, which corresponds to P wedge Q. Okay, and here's another example here with any statement P. Okay, so in this case we have R taking the position of P. We can conclude P, okay, so again R takes the position of P here, okay, wedge, okay, any statement we want, doesn't matter, okay. In this case, Q is Q horseshoe T, okay. So here again we have an example of addition, okay. Now here we have an example of something that you might think is an addition, but it is not an addition. Why? Well, look here. For the statement here, okay, the premise, we have the statement P dot Q horseshoe R dot S. However, in the conclusion, we don't have the disjunction, okay, of this statement, okay, if this statement is P, we don't have the disjunction of this statement and some other statement, okay? What we have is the disjunction of P dot Q, okay? So P dot Q disjunction with T, okay? Now, T might be Q, okay? But what is this statement here? It's not P, because P is P dot Q horseshoe R dot S. And here we only have P dot Q. So here we have a completely different statement than the statement that occurs in the first premise. So here we have something like R, okay, wedge Q, okay? So this is a completely different form than the form of the addition over there, okay? Now we can turn this into addition if we change the conclusion, right? So if we change the conclusion from taking this part here, one of the disjuncts, and making it P dot Q horseshoe R dot S, okay, together with the disjunction T, okay, which is this part over here, okay. Now if this were the conclusion, okay, this would be an example of addition. But this is not the conclusion that was given, okay? The conclusion that was given was this, okay? So this, as it is given, is not an example of addition.